Greetings to you and welcome back. My name is Fatima Garba Yusuf and this is Khaliltronics. Do well to like, subscribe and engage on our channel. Meanwhile, we're still on corrosion and this is going to be the last video on the series. So we're going to solve a question on oxidation kinetics. And in this question, we're given a table where we have some readings, some values of weight and some values of time. Then we're asked to determine whether the oxidation law followed is linear, parabolic, or logarithmic. And then based on the answer in I, we should compute W when T is 600. So we're given values of W when T is 10, W when T is 30, and W when T is 100. We're then asked to compute W when T is 600 based on the determination that we will do in the I section of the question. So if you could recall that our laws are actually linear law is equal to W equal to KT, where, like I mentioned earlier, you can include a small subscript of L here to show that it's the constant for linear law. For this, you can include a small subscript P, and for this, you can include maybe a subscript G to differentiate it from the subscript for linear law. So, like I mentioned earlier, if we're going to solve questions pertaining to this oxidation law, we'll first start by testing for linear law. And to do that, we simply take any two sets of values and compare whether their value of KL is the same. So we can make KL subject for the formula. Let's start our solution. So testing for linear law. We will say, okay, our KL is equal to W over T, right? So we'll take two sets of values and calculate their value of KL. If they both give us the same value based on the formula of linear law, it simply means that the set of values follow the linear law. So let's see. For the first one, let's say A. We can take the first run and the third run. KL is equal to 0.527 divided by 10, and that's equal to 0.0527. That's when W equal to 0.527 and T is equal to 10. So for the second test, that's B, you can see KL is equal to, now take maybe the third one, and here it will be even easier for us to determine whether it's the same because 10 and 100 are actually multiples. So typically if it were following the linear law, then the values of our weight in 1 and 3 will actually be similar, just maybe a difference in the position of the decimal place. But anyway, let's calculate it and see. Here when W is equal to 1.528 and our T is equal to 100, our KL is going to be equal to 1.528 divided by 100. And for this, we just simply move the decimal points 2 times backwards, giving us 0.01528. Now you compare this and this. Are they similar? Are they the same? No. Even when you round up this, it will be 0.02, not 0.05. So you can say that it's not linear law. So you go to the next law. It's important for you to move gradually from linear to parabolic and then to logarithmic, because in the linear scenario, it's actually easier to calculate your K. In the parabolic, you have 2 constants, and in the logarithmic, you have 3. So it's better you go gradually. So next, we are going to test for parabolic law. Testing Here we are going to take the same values we used to test for linear law. Let's say this is C. We'll say W is 0.527, right? 0.527 squared is equal to our Kp, which is unknown. Then our T is 10 plus your C is also unknown. That's your equation 1. Then for your equation 2, you substitute the other values. Here your W is 1.528, so it's 1.528 squared is equal to Kp into your T, which is 100, then plus C. So ideally, the way you will be able to determine whether your set of values follows parabolic law is, after calculating your Kp and your C simultaneously, you get values of Kp and C that will satisfy both these equations. Then you carry your values of Kp and C that you have calculated and substitute using the values of the third set that you didn't include in this calculation. So if it balances the two sides of the equation, if they balance, then that means that indeed the equation is parabolic, because of course the values of Kp and C are supposed to satisfy all three equations if it's following the parabolic law. So in this case, it will be easier for you to use your calculator to solve for your values of Kp and C. And please don't make the mistake of thinking that this is these are quadratic equations, because actually these are just values, and you can rewrite these to be 10 Kp plus C is equal to 0.5277 square. You can calculate that to give you 0.2777. That's your equation 1, right? And here you have 100 Kp plus C again is equals 1.528 squared, which will give you 2.3347. So here it looks clearer as a set of linear equations, right? So if you're using your calculator, you substitute the values of 10 and 100 as the coefficients for your first variable Kp, and for the second variable, in both cases the coefficients are 1, 1, while your constant value is 0.2777. So if you like, you can solve this manually, but I'm going to make this video short, so I'm going to just calculate the values and impute them. You can pause this video and try solving it yourself and then compare your answers with what I have here. From my calculations, I got Kp is equal to 0.0229, while I got my C is equal to 0.04917. It's better to use more decimal points so that you can minimize your error when you decide to substitute in the third equation. So in the third equation, or should I say in the third set of values, that's the one that you didn't use when solving for Kp and C, we have our W as 0.857 and our T as 30. So we are going to substitute these values here. We already know that our parabolic law goes thus: W is equal to Kpt plus C, right? So for the third equation, we have W is equal to 0.857, while our T is equal to 30. So we're going to substitute all these values, or we can decide to leave one out. It's either you substitute your value of W and see whether the value of T you get is the same, or you substitute the value of T and see whether the value of W you get will be the same. So since W is alone in its side, I think it will be better for you to leave W unknown and see whether what you are going to get by substituting the values of K, P, T and C will be equal to your value of W here. Alright, so I'll say my KP is 0.0229 multiplied by my T, which is 30, then plus my C, that's 0.04917. So I'll see whether it will give me 0.857. Now 0.0229 multiplied by 30 will give you 2.29 multiplied by 3, right? And that's 0.687. So we have 0.687 plus 0.04917. So you add these up and it will give you 0.736. When you add this up, you get, and when you remember that actually this value is not just W but W squared, so this will prompt you to take the square root of this answer to see whether it will give you this W. So it depends on how you approximate. You can get 0.736 and so on and so forth, but when I'm using this rounded up because so that you see that even if you approximate, it will still be along the range if you didn't do any major mistakes. So here we have gotten our W squared to be 0.736. Hence our W is going to be the square root of 0.736, right? Yeah. So our W is going to be square root of 0.736, and of course our value is not going to be negative, it's going to be positive, and it's 0.8579. Now this of course is similar to our value of W, so we can say that indeed our oxidation law followed is parabolic. And of course it's even more common that law is going to turn out to be either linear or parabolic because they are easier, especially when you're writing exams or if it's an objective question, because the third one is more difficult to prove. And of course, even if when you calculate your linear and your parabolic, especially in objective test questions, you are not sent to just go and start searching for or calculating or proving the third logarithmic law. Instead, if you just calculate that your linear and your parabolic are not the desired laws, you just conclude that it's the logarithmic law. Now let's remember that in this case we're asked to compute further, that we're supposed to calculate W when T is 600 if the answer is linear or parabolic. You see, even here they've simplified matters. If we had determined that our law is logarithmic, they didn't ask us to solve this question number 2. And maybe this will even give you a hint that the answer will have to be maybe linear or parabolic, except if they are going to test it, because why put a question if they don't want you to answer it? So in this case, we're going to use our formula for parabolic to calculate W with T equal to 600. So we'll go to our section 2. We have W squared is equal to KPT plus C. And because this is actually parabolic, it has satisfied all these equations, it simply means our values of Kp and our values of C are correct. So I'm going to substitute everything here. And our Kp is 0.0229 multiplied by 600, which is our time, then plus our C, which is 0.04917. Hence, if you calculate the 0.0229 by 600, it will give you a value of 13.74. You add it up to 0.04917. That's it. It gives you 13.78917. But remember, we're asked to calculate W, not W squared. This that you got is W squared. So our W is going to be the square root of our W square, right? That's the square root of 13.78917. And you get a value of 3.713. That's your answer. Meanwhile, if we take a look at this table, of course, it's obvious that the values of weight increase directly proportionally to the values of time, but there was no way for us to determine whether it's linear, parabolic, or logarithmic, except when we try to impute the values in these laws to determine whether it's linear, whether it's parabolic, and if not either of the two, then it's going to be logarithmic. So this is how you determine the law that a specimen or a sample follows with regards to the weight change with respect to time. So thank you for hanging on. Kindly subscribe to this channel, give a thumbs up, and see you in subsequent videos. Thank you for watching.